but we have basically 6 major objectives. So what are we going to be focusing on here? First thing is, what is JSON? Many of you probably already have a basic feel for JSON. Some of you may have been working with it, but we're going to start from the beginning. We won't spend that much time on it, but we'll review what JSON is, what it's for, its purpose in life, and the syntax for a JSON structure. Secondly, we're then going to go into, all right, well, once we have a JSON document, we want to store it somewhere. Where are we going to put it? Probably in the database. How do we store JSON in the database? And typically, it's going to be in a column of a row. Every row will have its own JSON document for it in that column. And we'll see how to do that. Once it's in there, then the third thing, of course, you have to do is update JSON in the database. And we'll discuss the issues with doing that, how to do it, what some of the problems are with doing that, and how that's been resolved over time with new releases of Oracle. Then the thing we'll spend most of the time on is the next two, consuming data and converting JSON data into relational data. Consuming data is sometimes you don't need to convert JSON data to relational data. You just store the data, and when you need something, you need to drill down into a JSON document. Well, how do you drill down? What's the techniques for doing that? There are a few ways of doing it. They each have pros and cons, so we'll talk about that. Sometimes, though, besides consuming the data by drilling down and getting to the pieces you want, you really want to take that JSON data that's been provided to you and convert it into relational data, rows and columns. How do you do that? So that's another big topic. Lastly, if you do have relational data in your application, but now you need to send this to somebody else, because we're going to see JSON as a standard format to transfer data from one application to another, you may have to convert your relational to JSON data and to a JSON document, and we'll just touch on that and give you a feel for what that's all about. Okay. Next, what is JSON? Let's get started. It's a markup language. What's a markup language? Well, it's something that is used to mark up data in such a way that when you're sending some data to someone, you're not just sending the data. You're sending the data and an identifier for what that data represents. That's what really a markup language is doing. In the old days, we used to send comma delimited files, but unless you understood the structure, you didn't know what those numbers meant. You had to know what the columns meant. In a markup language, you get both pieces of information. And we call it a simple universal format because basically it is the standard format that's used now. Therefore, it's universal, and it's much simpler than the previous version. And by version, I mean a previous markup that used to be the standard in a lot of applications, still used in many applications, but not the standard anymore. And the previous one was called XML, Extensible Markup Language. JSON has replaced it in most applications for two primary reasons. One is JSON is a lot less storage. Since it's less storage, when you have to send a lot of data from one application to another, you're sending less bytes across the line, and therefore you get faster transmission. That's reason number one. Reason number two is JSON is a lot less complex than XML. Because it's less complex, it's faster parsing. If you're going to drill down and find something, you can find it a lot faster, and it takes less memory overhead. So it's going to be more efficient than XML. So JSON is the standard, and we call it now the de facto standard for document exchange. Is XML still used in places? Sure it is. And there are some advantages to XML, but in general, they're not worth it to learn all the complexity and the slower transmission and so on. JSON basically is used by almost every computer language. Everybody uses it because they know it's the standard way to transmit information. Okay, so that's what JSON is. What are the documents? They're basically text. Every system has its own way of storing dates and timestamps and numeric data, but character data is pretty much the same. It's all text. So JSON's standard way is it transmits via text. Well, what does that mean? You may have binary data. JSON does not support binary data natively, but there are workarounds like doing escapes and taking your binary data, converting it to characters, sticking it in the character string, and then converting it back later. We won't go into those details, but you can get binary data in there if you need to, but primarily it's processing text data, and the data that goes across the line in a JSON document is text. Okay, Oracle's implementation. It is definitely a work in progress. It was introduced in 12C. So if you have 12C, you've got all the basics to do JSON work. But there are holes, there are missing pieces. So you have to do workarounds and whatever, and we'll show you some of the workarounds, and we'll show you all the missing pieces and when they were enhanced in later releases, 18, 19, 21, we'll show you some of the major enhancements that you will be able to take advantage of when you get to those later versions, okay? As an example, 21C, which really has solved a lot of the issues of things we were missing before, it actually has a native JSON data type. No earlier version has that. So just like you have varchar 2, you have date, you have number, and so on, we now have in 21C a native JSON data type. And we'll see there are reasons to use that when you get to 21C. But most of what we're going to do, we're going to focus on the 12, because everybody pretty much is at 12 and above, but not everybody is up near 21 at all, that's for sure. Okay, we're providing an overview, therefore all the details aren't here. We're just giving you a cursory view. Our class, of course, goes into it a lot deeper, but we have here throughout this presentation, there are links to where you're going to go to get more information. Each release of Oracle has a JSON developer's guide starting with 12, and here's the links for the 12.2 version, the 21C version, and there are plenty of others. By the way, not only will this webinar be available to you, we will send you links so you can get to it, but the PowerPoint presentation I'm showing you, plus I'm going to be using a lot of scripts to show you how code actually runs. Those will all be available to you as well. Okay, what is a JSON document? What's the data format? What are the rules for a valid JSON document? Well, JSON only stores two things. It's pretty simple: objects and arrays. Those are the two key things in JSON. So what's an object? It's a collection of name-value pairs. So we have a name and a value. The name is emp ID, the value is 2257. Remember I said that an interchange type language is going to provide data, but also what does the data represent? 2257 represents the employee ID. Robert represents first name, and so on. Okay, so this is an object, but it's enclosed in curly braces. That's the syntax. Each element in the object is separated by commas. There's two parts to an object: the name, which is in double quotes, a colon, and the data, comma, and then the next part, the next object, the next element that's in that object, and so on. Notice, what can the data be? It could be numbers. It could be strings in double quotes, not single quote strings like we have in Oracle, but double quotes. Okay? It can be a number, either integer or floating point. It can be a Boolean, true or false. It can be the keyword null, or they can be much more complex. An object can contain multiple other objects. Or a element here, like let's say last name, could include, let's say I had another element called phone numbers. It could include multiple phone numbers for this person. When you have multiple, that's called an array. So an object can contain arrays. So what's the syntax for an array? Anytime you have multiple values for any one element, then that has to be in square brackets. And it's just the data values. Well, you already have a name for it, phone numbers, colon, and now you can have 3 phone numbers, or you would have last names, colon, and you'd have 3 last names. Must be, again, your data, which could be character or a string or whatever, and so on. And that is an array, but it must be in square brackets. JSON arrays are 0-based, not 1-based like Oracle PL SQL arrays. They're 0-based. The The first element is array 0. The second element in the array is array number 1, and so on. So let's look at something a little bit more complex. Here's a JSON document. It's an object, so it's got curly brace and close curly brace. And it has individual elements, colon and the value, element to value, element to value. And then it has another one, dependence for an element. And it can have multiple values, so that's an array, and therefore it has to be in square brackets. Then you have your closed curly brace to close your object. So this has an object with an array inside the object. And you can get pretty sophisticated. Here's an array containing multiple objects. They're all the colors. Look at this. Here's an array, square brackets, and within it, I have curly braces. And this can be embedded in something else. Here's an object containing objects and an array. Here's an object. The first element is first name. There's the value. Last name, gender, age. But notice address. Address has multiple parts. Therefore, we're going to make it an object. There's only one address, so all we need is curly brace, and we have the different parts of the address. Street address, city, state, postal code, and so on. Close curly brace. Now we have phone numbers. There can be multiple phone numbers. Each one is its own object in curly braces. There's the first phone number, type, and number. Here's the second phone number, but because there's more than one, it must be an array, so it must be in square brackets. Okay, so you just got to get the syntax right, otherwise you can have problems. And as you can see, since this can be built, it can get more and more complex as you build these more and more complex JSON documents. Okay, someone gives us a JSON document. Where are we going to put it? Well, first of all, the document is always text. You're going to store it in a varchar 2 if it's small, that up to 4K generally, or 32K if you have extended data types in your database. If it's larger, you need to store it in a clob, or believe it or not, in a blob. And Oracle actually recommends, if you have a lot of data, to store them in blobs, because the way they implement it, it saves space. But can be more difficult to deal with that, because you have to convert it into the blob and convert it back, and there are functions to do that in Oracle provided packages. But we're going to use clobs in our example, in all of our examples, for simplicity. So we're going to take this document, we're going to use a varchar 2 or a clob. We're going to use clobs, and we're going to store it in a column of the database. When you store it in a column, we're going to use a new check constraint. It's called isJSON. If you have a check constraint on a column that says isJSON, it has to be valid JSON. Oracle will check the JSON going in for an insert, for an update, or whatever. It must be valid JSON. If it violates any rules from JSON, it will fail. That insert or update will fail with this check constraint violation. Now remember, when you get to 21C, there's a JSON data type. Since you have a JSON data type in 21, you're not going to have this check constraint. Instead, you just say, here's the column, and its data type is JSON. And then that covers it and does everything for you. And the JSON data type in 21 also improves efficiency for DML and query processing, so you're going to use that. But until you go to 21, you're going to need the isJSON check constraint. Okay, let's see how it works. We're going to create a table with a JSON clob with an isJSON constraint and see what happens when we add good data and bad data. I'm going to run all these scripts. I have a number of scripts as we go through the webinar here. This is called JSON. This is called JSON1. And here's my JSON1 script. I'm just going to run that guy.
Excuse me, Jeff.
Yes.
So Gary's been doing a great job at answering some of the JSON questions that are coming in.
Mm-hmm.
One outstanding, what determines whether something is a valid JSON document?
Okay, good question, thank you. It's valid JSON document if it follows all those rules we just talked to you about. And we're gonna see that here in this example, but let's say you have multiple multiple objects separated by commas, but you forget to put them in square brackets. You violated a syntax rule. That's not a valid JSON document. Has to follow all of those JSON rules that we just chatted about. Okay. Any other questions here, Dave?
No, all good, Jeff. Thanks very much.
Okay. Okay, so I ran the script, and I'm going to create a table called departments JSON. It's got two columns, department ID, standard column, and department data, which is a CLOB. It happens to be not null, but I'm going to create it with a constraint. I'm naming the constraint. The constraint name is department data must be JSON. And here's the key syntax. It's a check constraint, and the check constraint you put in is the column name, which is department data is JSON. Table is created. If you go to insert or update anything in department data, Oracle will check all those syntax rules to make sure it follows those rules properly. So let's insert a record with one employee in the department table. So let's look at it. Department ID is going to be a 10. Department data, we know, is a CLOB, but it has to be JSON. So since it's a CLOB, it's character data, therefore it might open single quote, close single quote. This is SQL syntax, not double quotes, because this is a standard SQL command, so it's single quotes. Well, now I'm going to name my individual elements in the JSON document. I have an element called department name. Its value is administration. Because this is part of the JSON syntax, any character string has to be in double quotes, not single quotes. So this only has two elements, department name and employees.
Pardon me, Jeff.
Yes.
Sorry to interrupt, but we had a question earlier which was answered, but I'd like to reinforce it for all of the students. What's the case sensitivity of the attribute name and the data itself, the value?
Oh, that's a good question. The data values are whatever you give as the data values. So they're going to be case sensitive, like normal data values. They're going to go into your database and be case sensitive. It's a good question whether I can make this uppercase or lowercase. I am going to guess that I haven't tried that. I'm going to guess that if I make this uppercase, it might be a different element. But we'll have to get back to just make a note of that, please, Dave, and we'll get back to that user or everyone with what that case sensitivity is. Good question.
May I add something, Jeff?
Yes, please.
This is case sensitive. It's the names are the names as they are. It is case sensitive. That's
what I would expect.
If you were to search for an element employees and it was in uppercase and you searched for it in lowercase, you would not find it.
Excellent. Thank you. Good. Okay. So here I inserted one employee. I have a curly brace and a closed curly brace, okay, because I have one object. Three different parts to that object, but I have one object. So that row is inserted. If I select from departments JSON, sure enough, here's my data. No problem. Data went in as character data. Now let's insert multiple employees in department 20. Well, I'm going to try putting the department name in as marketing. And for my employees, I have two of them. So I'm going to try two elements separated by a comma. And as we said before, we're going to have a problem with that. Because anytime you have more than one value, you need to make it an array. And sure enough, what do we get? Error, ORA 2290, check constraint violated. You violated the department data must be JSON constraint. Exactly what we expected, because you did not put, since you had more than one element here. In the first one, remember, we only had one element, so it worked fine. But in the second one, since we had two things in there, we had two objects in there, then we need to put it in square brackets. And now we can put the first object in curly braces and then a comma and the second one. And this first one, remember, is going to be index 0. The second one is going to be index 1 when we start to retrieve them. If I select from my department's JSON, I get 2 rows. The first row has 1 employee. The second row has 2 employees in an array. Okay, so let's go back. And that was script 1 that we just went through to give you a feel for what happens when you create your JSON cloud and with the isJSON constraint. And now, once your data is in there, you want to update the data. Well, in 12, they never really got to implement update in the best, in the way we really want it. Why? Because if you want to update before 19C, you must update the entire JSON column. So you have to update the whole column. Now think of a JSON document that's kind of complex, and you want to drill down, and all you want to do is change the price of one product that's way down multiple levels. You can't do that in 12. You have to replace the whole JSON column. So let's look at JSON 2. These I pre-ran just to save a few seconds here. I'm going to update department's JSON, set department data equal to. I have a whole new string for department 20. That was the one with 2 employees. I just changed the first name and last name to bogus employee. And I had to update the whole column at once. And now I get that update. I cannot update a piece at a time. That's a problem. That's problematic here. Okay, but once you got to 19C, there's a partial way of doing updating pieces. There's a JSON merge patch function, but it's got limited capability. It was written in 21 and backported to 19. So once you get to 19, you can use it, but it's limited. You cannot patch JSON arrays. If you have an array, you must replace the whole array, and you can't put in null values. So those are some significant limitations. There is a link in this presentation, JSON merge patch, should you be in 19 and need to use that and want to use that. Of course, you can go and modify other pieces, but it is limited. The real solution came in 21 when we get to the next function that was higher functions that was released, which is called JSON transform. Much more complex. Well, more complex, not much more complex, more complex. But it supports updating, inserting, and deleting any part of any data. You can go into an array and delete one of the pieces of the array. There were 5 employees. You can delete employee number 4. You can change employee number 4. You can add employee number 6. You can insert them and so on. And there's a link here to that syntax. Should you when you get to 21, but you got to wait until you upgrade it to 21, which might be a while for us. So in most cases right now, most people are replacing full JSON data when they have to update it. A little inefficient, but that's the way it goes. Yes, Dave.
I'm sorry, what version of the database are you running your code on?
I'm running it on 19, but everything we run will run on 12. Everything we run runs on 12. I'm not running anything that runs above 12, that I need above 12 to run.
Brilliant, thanks.
We will do that in our class though, Dave. Then we will be showing you things and how they work in newer releases as well. Okay, next. Now we want to consume data. Well, we can consume data with something called dot notation. We know to consume data, we can select the entire JSON column, we get a character string, and then you can go and parse the character string. That takes a lot of work. We don't want to have to do all of that. So if we only want a piece of a JSON string to use, we're not updating. Updating, we know we can't update a piece in 12. But if we want to get a piece just to utilize, we can use dot notation to get any of the attributes you want. When you use dot notation, of course, it has to be on a column or data that is valid JSON. So if you're reading a column from the table, it has to have the isJSON constraint to assure that it's valid JSON. Okay, and remember, we're going to use, when we go into arrays, we're going to use indices starting with index 0 for the first element. Okay, and we're going to look at JSON3.SQL to see how this is done. And let's go over to JSON3. And I'm going to just rebuild my table, my JSON table. Remember, we have a check constraint. Department data is JSON. And I populate it with the 2 rows that we had before. One had 1 employee, one had 2 employees. Now I'm going to select, before the dot notation, I'm just going to select the entire JSON column. No problem. I select department ID and department data. I get the whole column. But I want to drill down and get one piece of the column now. I want one piece of information or some pieces of information. Well, I can drill down and get it and get the whole JSON data for just one department. I can do where department ID equal 20. That's no problem. But if I want to drill down and get one piece, I'm going to use dot notation. So it's called dot notation. So I try to do department data dot department name. That sounds like it should be valid dot notation. I'm pointing this out because these are issues you're going to run into. Turns out that's not valid dot notation. It says that's not a valid identifier. You look up the rules. Oracle says you must, for dot notation, you must identify the table using dot notation. So the next thing I had tried originally when I did this is I gave it the table name, dot department data dot department name. Well, that doesn't work either. The actual rule is you must identify it with the table alias. Okay, so I have to give the table an alias D, and then if I say D dot department data dot department name, now it works fine. That let me pull out one piece of my column. Okay, so I can go down and get a piece. Well, let's look a little further. Of course, you can use column aliases with this. You know, if you want to use your as department name, no problem. As department ID and department name, you can get that. Now let's see though, how do we get out a piece that's in an array? Okay. First of all, let's look at an array. We know the employees might be in an array if there's more than one employee. So we're going to do d.departmentdata.employees. We didn't drill down all the way. We just drilled down to the employees level. We know employees have different pieces, first name, last name, employee ID, and so on. So how do we drill down? If we do that, what we get here is we get the employee, since there's only one, it's in curly braces, but this one had multiple, so it has to be the proper syntax for an array, and Oracle returns to you that piece of the data. If you don't go way down to the bottom level and say, all I want is the employee ID, it returns to you that piece of data in JSON syntax, proper JSON syntax. So the entire array is displayed in this case. But what if we only want one element from the array? We're zero-based. There's an element 0 and an element 1. This one only has an element 0. The second row has an element 0 and an element 1. So what do? We say d.departmentdata.employees sub 0, and then we can drill down further and say which employee ID we want. So which one of the elements we want? We want the employee ID. That's all I want, and I'm going to call it employee ID. First name, last name, I got all 3. Sure enough, I get all 3 with the appropriate names. Of course, it wrapped it around because this is a SQL Plus kind of output, but you get the idea here. And this was employee 1, the first employee, which is employee 0. First employee was Jennifer Whalen for 10. First employee for 20 was Michael Hartstein. Now I want the second employee, so that's element 1. Notice for administration, there is no second employee, so it returns nulls. For department 20, there is a second employee, so it returns the data. So index 1 does not exist for department 10, so it's going to return a null. Well, that could be a problem, because how do we know that maybe there was really null data in that? Maybe there was an index 1 with null data, or maybe there was no second employee. How do you know which it is? Well, you don't from dot notation. A little later, we're going to learn that you can probably identify an error and determine whether it's an error or a null. And we're going to use the JSON value function to do that. Dot notation will not allow us to differentiate between a null value and a missing element. Okay, so that's one limitation to dot notation, and we're going to see other limitations. Here's something else you can do. I want all employee IDs. I want to select employee, and I'm not going to use a single index. I'm going to use a star. That's the syntax. Give me all employee IDs. What's the format going to be? Look what it does. For a single one, it just goes down and gives you the scalar, the individual data. But when there's more than one, it's going to include the data as if it were standard JSON syntax. So it gives you the multiple. Okay. In case of multiple, it's got an array, so it puts it in square brackets. So you can do that. So there's a lot of issues, a lot of things that you can do here, but dot notation does have one limitation so far that we saw. By the way, when you have drilled down, let's say you have a very complex JSON document, you have to drill down and down and down, getting the dot notation right, this dot, and the next dot, and index in, and the next dot, can be, a little problematic. So there are tools around, and one is called JSON Pathfinder. In JSON Pathfinder, with that free tool, you just load it up. It's on the internet. There's a link to it in the notes section of this slide. You go into it, you place your document in one window, you click on the piece you want, and the dot notation shows up in the other window. Okay, so that'll help you when you're doing applications with complex JSON documents. Okay, at this point, there's more JSON to come, but first, back to a brief commercial with Dave.
Thanks, Jeff. Hey, everyone, this has been recorded. We will post it as soon as possible. I'll send you an email with the link. If you look in your chat, you'll also find a link to where it is going to be posted, along with the slide deck with all the links in the slide deck and the scripts that Jeff is presenting with. Look, there's two things that you might be interested in. First of all, the JSON training class. And Jeff, if you could just show us the page for that. I'll put this in the chat as well. So we've got an introduction to JSON, hands-on, instructor-led online class. Hands-on, instructor-led by Jeff, online class. So what you're seeing today is a preview of the class. So, those slides, you may say, hey, they're not like normal SkillBuilder webinar slides. They're a bit dense, more information than a typical webinar slide. And there's lots of slides and lots of demos. Well, that's because it is a preview to this class, an introduction to JSON, where you'll get obviously hands-on practice with Jeff helping you, answering all your questions as you go. And we hope that you do register. There's 2 on the board coming up. We hope you do register. Now, the other thing is, many of you are involved in Apex application development. Well, so is SkillBuilders. And we are currently doing, Gary is on with us today, Gary Lawton. He is currently involved with a customer with a very heavy Apex JSON application, building an application for a retail customer. So we can help you if you have Apex application development needs that you'd like to outsource to us. We've been building Apex applications since 2008, so we have a lot of experience with our team. You've met Jeff here today, but Gary Lawton, Tyson Dugley, Lino, a lot of our team can help you design and develop your applications. Last thought, you might want some mentoring, which is a little bit of a combination, specifically training for your group. So we can make that happen as well. So back to the slide, Jeff, and There are a couple of questions in the queue, so thanks for your time on that commercial, but let's go back to the training here. And Jeff, let me throw a couple of questions at you that are pending in our queue. Do you know if Oracle gives you any clue as to what line in the JSON stream is invalid? The check constraint will tell you it's invalid, not where. Do we know of a parser anywhere that might help us drill down on the where the string is failing?
Yeah, good question. Gary, do you have you been using any of the parsers to determine that? I don't.
There are several online tools to check the validity of JSON. I do use one. I could drop it in the answer if you would like. But there are many out there. There are JSON validators. Of course, there are online tools to beautify. That means when they're in a string, they will beautify the JSON. And there are tools also, and which are, I would say, very, very important. And they are what are called JSON pathfinders. Because if a JSON document becomes, if the JSON document has got a very, very deep hierarchy, it can be of a great help, especially in Apex applications, to be able to use the Pathfinder to find the paths of the elements or the objects that you need, because especially when you are working with an external web service, these hierarchies can be very deep, and it's not a case of just converting to a table, very more of a flat table. They can be very deep, so a Pathfinder is really really essential, I'd say. And I can put the URL of the Pathfinder in the chat as well.
Thanks, Gary. Yeah, this is Dave. I answered with a Pathfinder and a validator as Gary was speaking. Gary, if you know one that you prefer, please go ahead and put it in the chat. That'd be fantastic.
Yeah. Okay.
Sorry,
the Pathfinder also validates, so the same one can be used for both. Okay.
Fantastic. Thank you. So question in about, will we show how Apex apps deal with JSON and the blob? Not in this webinar, not enough time for that. Obviously, we have lots of experience in that. As I just said, we're building a customer application with heavy use of that. We'll see if there's going to be another webinar or perhaps an addendum to the class. We'll see about that. So Mark, stay tuned on that. Might get back to you on that. Jeff, you talked about standard JSON escaping. Can you just give us a very quick review of that for us? Standard JSON escaping?
Yeah, you got to define specific escape characters. I'll get a link for that, and I'll put that. I'll send that out also. You have to find specific escape characters and take your binary data, convert it to character, and escape that part of the JSON document. And then it's known, since that's known as an escape character, then you can go grab it on the other end and convert it back to binary. And there are utilities, and I'll put the utilities in there too to do the conversion both ways.
Great, thank you.
Okay. All right. I mentioned there were limitations in dot notation. We said it can't differentiate between a null value and a missing element. That was a big problem. And we needed the isJSON constraint. By the way, sometimes your JSON data is not in the table within his JSON constraint. Someone just gives you a string you read from a file or some other way, or you created it some other way. Well, if you're going to use dot notation, you can use that, but Oracle has to know it really is valid JSON. And in Oracle 18c, there's a new function they released called the treat function. And you say treat and the character string, and it treats it as if it were JSON. It enforces that it's JSON. There are some problems if it's not valid JSON, so it may return incorrect things. So you really have to make sure it's valid. But if you know it's valid, you can treat it, and now you can go back and use the dot notation that we talked about before. Okay, I'm going to skim through this because I want to make sure we get to as much as we can.
Right,
so we
Jeff.
know that, yes?
Just watch your time, thanks.
Okay, JSON dot notation is limited. There are basically three functions that Oracle has provided: the JSON value, the JSON query, and the JSON table. All are provided as of Oracle 12, so you don't have a problem there. And let's get into those as much as we can. You're going to use JSON value to get a single value. So if you're going to drill down and get real, just plain data and a single value, you can retrieve the column and parse it yourself, which is very inefficient writing your own code. So instead, you're going to use JSON value to drill down and get that single value. JSON value is a function, takes two arguments: a JSON column name, okay, where's the JSON data, and a path expression that says, how do I drill down? The path expression is a character string that starts with a $sign and follows certain rules, so we'll see that. Okay, if you have JSON value and you drill down to and you're supposed to drill down to a scalar value, but you don't go down far enough, and what's would be returned is not a scalar, Oracle raises an error. You got to go down all the way to a number or a character string or date or whatever, okay? Or a Boolean or whatever. JSON value returns a null by default if no value is found. So if it finds no value, let's say you want the second element in the array, you go into index 1, but there is no second element like our employee, well, it's going to return you a null, which we saw before, but it really returns an error. Doesn't really return a null, it returns an error. But the default for JSON value is null on error. So since it returned an error when it couldn't find it, it's just returning a null. Well, how do we know that it differentiated between the null and an error? Well, the way we know, we couldn't do it in dot notation, but we can do it with JSON value because we can change the default null on error. We can add a clause error on error. And JSON 6 does that. So let's, JSON 6 does that and shows the error on error clause. We're running a little low on time, so I'm gonna skip that. You will get the JSON 6 query, so you can look at that yourself. And I'm gonna move on a little bit to show you the path expression that you're gonna need. To go on to JSON query. That was JSON value. Now JSON query takes it a step further. JSON value, you had to drill down to the actual bottom level. JSON query, you can drill to any point, and from that point on, it returns to you all the data as a character string in JSON format. If it's an array, it gives you the square brackets and all that nice stuff. The difference between the value and the query is a little bit more complex. It needs a returning clause. And in 12c, the only returning clause is varchar 2, unfortunately. So that's a limitation in 12c with JSON query because you can only go to the longest varchar 2. That's been fixed in 18c. You can say it's a clob or a blob. So as of 18c, you've got that issue. If you say varchar 2, let's say 4,000, and it returns something bigger than 4,000, it'll give you an error. And the error by default returns a null, and therefore you'll get a null. And if you don't want to get a null, you can add the error on error clause. So if it's larger than your varchar 2 in Oracle 12, it will now return an error, and at least you can detect that. And this is script is in JSON 7. So 6 and 7 show you how you use those two things, the JSON value and the JSON query. JSON query requires one other thing. It needs a with wrapper, and usually use pretty with wrapper whenever you're returning more than one object. So if you're expecting an array, you need an extra clause that says pretty with wrapper, and then it'll wrap the data appropriately so you can see it. Let's see. Yeah, we only have 10 minutes, so unfortunately, I'm gonna have to skip that stuff at this point. We will get into that more at, in a class, of course. But the key thing that I wanted to then make sure I get to is JSON table. Now, JSON value gives you a single scalar. JSON query gives you a fragment. But what does JSON table do? It allows you to convert your hierarchical structure of a JSON document into relational data, so you can take that data from your JSON document and move it into a relational database. So what can you do once you do that? You can get standard columnar reports, you can insert it into relational tables, you can create relational views from your JSON data, all really cool things to do. So the solution to that is JSON table. Okay? Now, in our example, we had basically two departments and they can have multiple employees. We only had 2 employees. We could have hundreds of employees. Okay, so basically, if we had that in a hierarchical structure, we would have a department table and an employees table. And what would we do with that? We would have a primary key in the department table, a foreign key in the employees table, and we would join the 2 tables, and we'd wind up with 1 row for each employee with that employee's data for the employee and that employee's department data. That's typical joins. Okay, how do we get that with JSON data? And once we have that, then we can put our data into a relational format. We use JSON table. How does JSON table work? It's a little tricky, not too tricky, just a little tricky. If you had 2 tables, a department and an employee, you'd list them both in the from clause, and you would join them together. Well, what JSON table does is it creates a table with 1 row for each value in the JSON array. So if you have a JSON array with many employees, it's going to take that 1 array and create 1 row for each one of those. So in essence, JSON table creates, in essence, something that looks like our employee table as a relational construct. The base table might have many other columns. That's like the department table. So all you do is you list 2 tables in the from clause. You list the table resulting from the JSON table function in the from clause, and then you list also the table containing the JSON column in the from clause. Now you've got 2 tables, one that looks sort of like the department table and one sort of like an employees table, but not as an array with 1 row for each employee, and you want to join them together. But you don't have to join them together because Oracle knows this is a JSON table function and knows what you're trying to do, and Oracle will implicitly join the 2 tables, giving you 1 row for each element in the JSON array. That's really cool stuff. So let's look at one more script. We have time, I think, for maybe one more script, which is going to be JSON 8. And let's take a look at that. Okay, so we are going to use the JSON query. The JSON query, we haven't gotten into this sort of notation to drill down. And remember, it said it was JSON, a special JSON dot notation, a character string, and it started with a $sign. Well, it starts with a $sign, and here we're going to say drill down to the employees. Okay, drill down to the employees, and you need a returning varchar2 with a pretty with wrapper. This was the JSON query that we skipped over and we didn't do before. JSON query needs the same kind of a thing. All right, so we drill down here, but the problem is with JSON query, JSON query, remember, returns part of a JSON string. It does not break the array into multiple rows. So JSON query is going to return to us our 2 rows, but it's going to have just those pieces of information. And excuse me, 2 rows, but the second row has only 2 rows. The second row has 2 employees. That's the key. It returned 2 rows, but we use JSON query, not JSON table. So therefore, it did not drill into the array and give us 1 row for each element of the array. But JSON table is going to do that. So here, we're going to list in our from clause the containing table, which is departments JSON, and a second table created by the JSON table function. What do? You have to tell it where is the column that has the JSON data, and then you need some special syntax. Here's your $, and then you specify what columns. There was a column name in that second column, okay? In the department data column, there was a department name, but the employees was in an array. And the syntax for that is nested employees. So basically unnest the employees. They're nested, unnest them, and return to me these 3 columns. There are only 3 columns there, but you could return part of it or all of it, any of the columns you need. So this JSON table gives you a relational table that kind of looks like it's got the department name and the employee's ID, first name and last name. And Oracle will join that with the base table that had the department ID. And sure enough, what do you get? You get 1 row with the first employee, but then you get a second row for department 20 with its first employee, and then a third row with department 20 with its second employee. And if we want to look at that in a nicer way, I ran it as a standalone query result, and now you have relational data. That's really cool stuff. That is really cool stuff. It really allows you to take your data, convert it to relational data, and do whatever you need with it. Okay, that's about all we have time for, I think. So I'm going to basically turn it back to you, Dave. And thank everybody for listening. And I appreciate it. Sorry we couldn't get to more, but that's about all we had time for. All yours, Dave.
Hey, thanks, Jeff. Thanks very much. So there's a question about subquery factoring out there with the JSON structure. So we need to test that, see if that's going to work out okay. So pause on that. One other question, if we create a JSON object that we create on the fly, can we access it with JSON table? Can we read it with JSON table?
Yes, you can, but you're going to have to use the treat function in Oracle 12 so that Oracle knows it's really JSON data.
Excellent.
So once you give it the treat function, it's just as if you had to use JSON or the JSON data type. It knows it's JSON data.
Jeff, I'm not familiar with the function. Is it tree or treat? Tree?
Treat, T-R-E-A-T, treat function.
Thank you. Beautiful.
It was in one of the earlier slides, and when you guys will get the slide deck and so on, and the labs, including the ones that I didn't do, you will see it in there, and you'll see some examples in there.